Hey everyone, I'm here with Erik for another deep dive into an exercism exercise. And this week we're looking at raindrops, which is a really interesting exercise. There's loads of different ways to approach this. It's another one of these exercises where there's quite simple solutions, but we can get into all sorts of really interesting ideas further down the line. We've got pattern matching guards, we've got branchless solution that uses lookup tables. What else do we have? We have a really interesting object-oriented approach. We've got all sorts of stuff. It's going to be a really fun little drive for the next sort of half an hour, 40 minutes through different ways people look at this exercise. I'm with Erik again. Erik, how are you?
I'm doing well. How are you?
Good. Yes, I am doing well too. Thank you. I'm in sunny Madeira today, which is one of my favourite places in the world. So shout out to anyone from Portugal or from Madeira. Yeah, I love it here. Always puts me in a good mood, which is good for these videos. So firstly, we should probably just look at what this actual exercise is. Many of you will be watching this video having just completed the exercise, so you'll know what it is. But for those of you that don't, you get given a number, and then based on the factors in that number, you're putting together a string which is made up of plong, pling, and plang. Three numbers that sound like raindrops hitting a surface, maybe just outside your window. And this is based on the classic exercise of FizzBuzz. I think FizzBuzz is like a more simple version. This is a slightly more complex version. Is that right, Erik?
I think FizzBuzz has fizz and buzz. So I think it has just two factors, and this has three. But there are many variants of FizzBuzz, but it's a classic, like reverse string, by the way. It's a classic one where people get asked this in interviews.
Yeah, we looked at reverse string in the last video. If you've not watched that yet, do give that a watch. It was fascinating how complex reverse string gets. We were looking at pointers, stacks versus heaps, all sorts of different things that you can do, different algorithms. But let's focus in. So we've got this first solution up here, which is Benjamin ADK's solution in JavaScript. And I guess this and the next couple as well are all very similar, Erik. They're sort of the most basic, simple ways to solve this exercise. Do you want to just talk us through very quickly what this is?
Yeah, the first couple of solutions will be very hard-coded. So you can see basically the exact rules that are specified in the exercise. So they start out with a variable output that's an empty string at first. And then there are three if statements. And that if the first one checks if the number that's get passed into the function is a multiple of 3, which means that the remainder of 3 is 0. And if so, pling is added to the string. So the string was empty, so that would become pling. Then the second if statement does the same thing for multiple of 5, adds plang, 7 adds plong. And then the only business rule left to implement is to check whether or not any of the rules matched. And in this case, it uses JavaScript's typing system to, output is, it's a string, but it's also a interpreted truthy or falsy. So if it's an empty string, it's actually false. But if it's a non-empty string, it's true. So you can read that if the output is not empty, then return the output. Otherwise, return the number, the string variant thereof. So this is very basic, just very concrete, easy to read, easy to understand based on the domain and the business rules.
Nice. And of course, there is the challenge here that JavaScript, as you said, treats an empty string as falsy, which is quite unusual. Not many languages do that. But it does mean that, this is a nice, elegant sort of final line of code there. So this is pretty simple. I imagine this is the sort of solution that most people come up with on their first pass. And if we jump into the Kotlin solution, this is very similar. It's just using a string builder, basically, Erik. Is that right?
Yeah, it's using a string builder. And we discussed in the reverse string video that building a string can be quite memory intensive. So there are ways to do it in a more efficient way. And one of them is to use string builders. And the JVM has a string builder type. But Kotlin has a very nice domain-specific language around that. And that's called build string. So it's basically you're using a string builder, but with some very nice syntax. And other than that, it's almost the same. Now you have is empty because Kotlin does not have that the truthiness, falsiness of JavaScript. So it's you have to call a method for that, but it's still very nice. So, but this is more optimal.
It's interesting. Yeah, it's interesting syntax. This I've not seen this before. So within this sort of build string block, you get presumably append and is empty that are working, like you said, as methods basically on this object.
Yeah, they are.
Is this something you see a lot in Kotlin?
Yeah. Kotlin has a lot of those domain-specific language builders. So there are other ones too, but this is a very common one if you're building strings. And it's almost as if you're in within those curly braces of build string, you're in the object. So you're calling the append method, but you don't really see the object that is being called on. So that's a bit of a nice syntactic sugar. But you can almost, if you squint a little bit and you put in a string builder dot before it, you would have the same code. But it's just a nice syntactic sugar.
Very cool. Yeah, I like that. I've not seen that before. That's really nice.
It is.
And then the third one of these sort of three that go together is Rust. We had comments on the last video telling us that we hadn't put Rust as one of the examples. As much as we like Rust, we're not going to be putting Rust as an example in every single video, much to the sadness of all of the Rust fans out there. We're going to try and mix it up with some different languages, but we are featuring Rust as one of the languages in the video here. So, Erik, this is using, I guess, a vector instead of a string, is it?
Yeah. So if you look at the basic approach, you see either people appending to a string or building a list or an array or a vector of strings, and then later on checking if that list or string or of a list or array is empty, and otherwise they will return a number. But if it isn't, there's like a join functionality usually. So that's in line 16 here. So this is just something that people either they have a preference for appending to a string, or they might remember that appending to a string is relatively expensive. But then again, allocating a vector is usually also not that inexpensive either. So I don't know what the best way is, probably just the regular string one. But this is equally valid. So and this is something that you'll see in later. So this being creating a list of the values is something that we'll see later on. And I forgot to mention something at the beginning. The solutions that we are showing are not necessarily the idiomatic ones in the language. They are just examples. And so this can be written in Rust, but there could be other ways to write this in Rust that are more efficient. So this is not necessarily the best way to do it in Rust. It's just one of the ways that you can solve it.
Yeah, we're just picking out fun solutions that we like the look of as we go through. The language is often incidental. Sometimes, like Kotlin, we're showing off little nice features of the language. But yeah, really, we're just finding solutions that highlight the sort of features we want to talk about. So those three are together. Those are, as I said, the basic ones. If you put one of those solutions together yourself, that's great, nice work. They're totally sensible solutions. If you went and got mentoring on Exercism, your mentor might challenge you and say, well, how about if we want to make this a bit more extendable? And as we move forward into this next solution in Scala, which is your solution, Erik, I guess this is the first one where rather than just having hard-coded lines of if this, then, if this, then, if this, then, we're starting to now think about extensibility a bit more. I can see you've used a map at the top here. Do you want to talk us through this one?
Yeah, and that's exactly the reason why FizzBuzz is a common question in interviews, because the natural solution for people will just be to use if statements, and then they'll say, hey, what if we add 10 more sounds? You would get, if you would keep on continuing using the if statement, it will be a huge amount of code. So the idea is to separate the definition of the number to the sound from the actual logic that checks whether or not the number is a multiple. So this is the Scala version, and the key thing is that drops here is a map or a dictionary, depends on your language, or an associative array. There are many different names for it. But you're basically, the key is the number, and the value is the string. So 3 is associated with pling, 5 with plang, 7 with plong. And then we have to iterate over those elements within the map. So that we can do that here with a for comprehension. So the syntax you might be slightly unfamiliar with. So if you focus on the factor comma sound and then the left arrow drops bit, that's saying for everything that's in the drops value, which is a map, extract the key and the value to the factor and the sound variable. And then there's a postfix condition. So that's the if statement. So if the number is this number is a multiple of the factor, so that's the percentage check, then we yield sound. So this is a way of, this can also be written differently, but basically it almost looks very imperative, whereas this is in effect functional. So you can still see this as a sort of pipeline. We'll see that later on. But the idea is that now we have in a single place the numbers and the strings. And if we were to extend this, it would be, we have to do it in just one place. We wouldn't have to change any of the body of the convert function. And then the actual implementation of the rest of the convert function is, well, it's very simple. If sound is empty, so then we return the string version of the number. Otherwise, we join it. So mk string is the joining. So this is also is not returning a list, it's returning an iterable, but you can think of it as a list. So it's a collection of values that is being returned here. So that's what it shares with the Rust approach, the fact that you're working with a collection of values.
Nice. I'll show my Ruby one as well here. So basically, a very similar approach in Ruby. This was how I solved it when I did this, and very much the same thing. Creating a hash in Ruby's terminology, going through, selecting the keys that match, getting the values out, and then joining those together at the end into a string. So I think this is the sort of approach where if you take an extensible approach, I think this is the first approach many people come to. It's probably the most lightweight way of just in terms of the lines of code that you're writing, the readability of it. I think just a really simple, slick solution that's extendable. This again would be, I think, a good answer in a job interview or something. But as we move forward, we can start to do some more interesting things, Erik. And looking at your solution in F#, it's again very similar, but you're now starting to use, I guess, pipelines here.
Yeah. So this is just to show that the Scala version did use variables or values, bindings, whatever you call it. Mm-hmm. So it's still imperative-like to some people, although it's still completely functional. But you don't even need that. You don't even need those intermediary values. So this is sort of the same thing. So we're starting out with, in this case, a list of tuples. So we have an element where a tuple with the first element is the number, the second is the sound, and then we have three of those. And then we do list.choose, which is a higher order function, very functional. And then basically we're doing an if statement. And we're saying, hey, if that number is a multiple of the factor, then we return sum with sound. And that means we've found a value. Otherwise, we return none. And the list.choose function will only return the values where you returned some sound. So any none values will be ignored. So you only get the sounds. So the end result of list.choose is a list of strings, the list of the sounds. And then the only thing that we need to do then is to have our final bit of business logic. So we pipe it into an anonymous function, which we do pattern matching. So this is very functional. So we pattern matching on line 7 on the empty list, which means that we didn't find any sounds. So we just return the string representation of the number. But if we did find the sounds, we assign it to a variable, and then we concatenate it with an empty string. So that means just, the sounds are concatenated basically. So this is very functional. Pattern matching, higher order functions, option types, tuples. So if you're a functional programming aficionado, you'll like this, I guess.
Yeah, for sure. What is the sum? Is that just type that you're saying this is something, but you don't really care what it is? Do you have to specify that type there?
So sum is what's called an option type in F#, and in other languages too, and some languages call it maybe. I don't even know if there are other names, but maybe and sum are the most commonly used ones. And it's basically a different way of working with null. So many of our C-like languages have null, which represents the absence of a value. But we all know that there's the infamous null reference exception. And we don't want that in a functional language. So in functional language, you create a type to represent the same thing. So the type is an option type, and it can be either sum with a value, which means that there is a value, or it is none, and that means there isn't a value. So and in this case, what we're actually returning is an option string value. Mm-hmm. So there will be some string or none. So that's what the option type does. It gives you a type-safe way of dealing with values that might not be there.
Nice. As a side note to this, we're building a new platform at the moment, sitting alongside Exercism, which is just for people who are learning to code from scratch. We'll be releasing it later in the year if you're watching this when we release the video. But for that, we're building our own programming language, which enables us to do lots of things. But Erik just dropped me a message on Slack the other day, said I'm just about to add the $1 billion mistake, which is the concept of null, Erik, in the language, which gave me a chuckle. But yeah, cool. Thank you for explaining that. It's good to see. Good to see all these different ideas in functional programming, which won't be familiar, I know, to a lot of people. But something people want to really get into, but also nice to see things like option types and things being showed off there. So next we move on to a solution in R. I know you were quite excited about this one, Erik. I guess, again, for people that aren't familiar with R, there's a bit of stuff in here that's going to feel a bit confusing. So maybe you could just talk us through it again.
Yeah, so it definitely shares a lot of with the F# and the Scala version, where we have sounds being defined as a pairing of the string and the number, but it's a vector. So in principle, it's the values 3, 5, and 7, but each value also has an associated name with it. So you can almost think of this like an Excel sheet where you have values and you have columns, and the column will be the names or the rows, whatever. But the interesting thing about R is that you can do vectorized operations. So that it will be, if you have never seen that will be very, very weird at first, but it's incredibly powerful. Mm-hmm. So basically what you should focus on first is the bits where it says sounds and then opening square brackets, number, percentage, sounds equals 0. So what that will do is it will internally iterate over all the sounds within that sounds vector, and then it will say, hey, if the actual sound modulo the number modulo the sound is equal to 0. So that's our regular check to see if it's a multiple. But we're now doing that percentage on the entirety of the vector, so not on individual values. And what that will return is a vector of true or false values. So that might sound very weird, but let's make it concrete. Suppose number is 15. So we would do 15 percentage sounds. So that would apply the percentage operation on the first element in the sound, which is 3. Then it would do that to the same. So in this case, the input number was, I think I said 15. So that is a multiple. So it would return true. For the second value, it's 5, which is also a multiple of 15. So it will return true again. And then for the third one, it will return false. So we now have a vector of true, true, false. And then what we do is, maybe you've seen slicing or indexing, but you can index a vector based on true and false values. And what that will do is it will return the corresponding element. So if we have true, true, false, we get the first and the second element returned, but not the third. If that vector would be false, true, false, we only get the second element returned. So that is a very, very concise way to filter the entirety of the vector without having to do any looping or whatever. And then the rest of it is, well, fairly basic. We have names, and names is to extract the name from the actual values. So that's what I mentioned before. When we define the sounds vector, every value has an associated name with it. So now we are no longer interested in the values because we've done that check before. We've only filtered, everything that is multiple. Now we are only interested in names, so we're getting the names, and then paste 0 with collapse empty string. We'll just concatenate them. And then on the final line is basically saying, hey, if this is not empty, then return it. Otherwise, we return the string version of the number. But the key thing is that you can just use these operations that you would normally apply to individual values, but you can apply them to an entirety of a vector, so multiple values at once. That's the key thing here.
And that multiple values at once thing is extremely fast. And this is, many of you will know, but for those of you that don't, a big part of how machine learning and neural networks, things like ChatGPT are working, is they're using these vectorized operations on GPUs where you can take these huge vectors and run calculations simultaneously on all of these values. So not only is this a really cool way of doing it, and when there's only 3 things in the vector, the performance isn't going to make too much of a difference. Mm-hmm. But from a conceptual perspective, this is a very, very fast way of solving this exercise as well. Really, really like this one, Erik. It's
I love this solution.
It's really fun, really clever. Yeah, it's really good. So yeah, cool. Okay. So then moving on to, I guess, a totally different way of approaching this, which is your pitch's solution in Python. Talk us through this one, Erik.
Yeah, so I've had multiple people suggest something like this, and I've chosen this version because it's very readable, I think. So it also has bits and pieces of previous ones where the drops are defined separately. So there is like a sequence of those tuple values. But the key thing that this solution recognized was that pling, plang, and plong only differ by a single letter. So the rest is all the same. So we can sort of see the Scala-ish solution where you have a for loop. So for I, v in drops, that's iterating over all these, both the sound and the actual number of the drops array. But then what it does is only has the single letter. So you have the F and then the double quotes PL and then between the braces I. So that's basically substituting just the single letter that is associated with that factor. So this is very, very efficient in terms of having no duplication at all. So we never see the string pling, plang, or plong. We just have I, A, and O, and it will be dynamically filled. So this is, I think, if you've understood the Scala version, this will be easy to understand too. We have a postfix clause, if not num %v, that abuses the fact that in Python you also have truthiness and falsiness. So num %v will be 0 if it is a multiple, but 0 is false. So doing not means that it flips to true. So this means that if it is the multiple, then 0 will be true. Otherwise, it will be false. And then it uses the fact that if the entirety, so the joining of all those factors, if that is an empty string, that will also evaluate to false. And then you can do or, and you have string of num. So that's the other case. It's sort of a bit reminiscent of both the JavaScript version with the truthiness bits of the Scala version where you have the for comprehension. But this time it's just recognizing the fact that you just have to use a different letter for the 3 different cases.
What I really like about this solution is how it sort of uses the strengths of the language that it's working with. Like it uses the strong elements of truthiness in Python, as you explained there. It uses the list comprehension by being able to put the if not num %v on there. So as well as just sort of the observation about the pling plang plong sharing 4 of the 5 letters. I think, using those Python features like this, I think it is a really, really nice solution, because this isn't a line of code that you could write in most languages. Most languages, you would need to do other things, have other intermediate variables or more pipelines like you showed. So I think this is a nice little masterclass in Python, as well as using some nice things. I'm a big fan of this. I think this is a really, really elegant way of solving it. I guess the only problem is it's not that extensible. If for some reason a raindrop came down and made a splash sound or something instead, that would be where it falls apart a little bit.
It would.
But in terms of solving the exercise, it's nice. So next we're coming on to a Lispy version. I quite like always having a Lisp in each of these videos. And this week we're looking at a common Lisp solution. And again, this one's yours, Erik. I've encouraged Erik to use the same solutions, by the way. I think there's often cases where we can find solutions that are not quite as clear to understand, but it's nice for Erik to be able to take a solution, just polish it so we can show it off in these. So don't think that Erik is monopolizing his own solutions. That is something that I've asked him to do and we've thought about. Erik, you were going to say you've taken this from someone else's and tightened it up a bit.
Yeah, this is not my solution. I've adapted it from somebody else. I reformatted it slightly to make it easier to be displayed in this video. And I've removed a little bit that we don't need here. But this is Common Lisp. Well, a Lisp, of course. And the key thing here is that Common Lisp has a very interesting format function. And that format function is very versatile. So many languages have format functions where you can have like a format string where you have placeholders. So put in a string here, put in a number there, maybe add leading zeros or whatever. But I've rarely come across a string that allows conditionals to be specified in them. So let's just focus on that single line 10 where it says format. Nil is just to have it return a string. Otherwise, it would return to the standard out. It would write to the standard output. But the format string has tilde square bracket pling tilde closing square bracket. So that says that if this is a conditional string, and it will only get printed if the value that it gets passed into it is equal to 0. So that is quite a thing, because you can see here that the argument after that format string is rem n3, which is the remainder of n by 3. So if that is 0, it is a multiple, then the conditional gets executed. So only when that value is 0, pling gets returned in the format string. And then the same applies to plang and plong, which are the other two arguments. And then the result of that format string is assigned to the result. And then you just check whether or not the length is 0. And if so, we convert the number to the string. Otherwise, we return the format string. But this is a very interesting thing, and I've never seen it actually, to have a format string where you can add conditionals. I just think it's sort of genius in a way. Also quite uncommon, so you have to get used to it. But I really, really liked seeing this. But it's probably not idiomatic code. But
well, I mean, it's in the language as a thing, so why not? Yeah, I think this is great as well. I would love to see a sort of maybe a macro-based approach or something as well, where the pling and the 3 are pulled out, and then the string is like built with its conditions based off a list or a vector or whatever.
Yeah, I actually tried to find one, but I found this so interesting that I actually used this one. We have a macro-ish solution later on, and I looked at the documentation of format. There's this only scratches the surface. You can do a whole bunch of things that we haven't even mentioned. So I think that's an extremely powerful tool if you master it.
Yeah, it's one of the things I love about these older languages that have been here for a long time. Is like, firstly, they came up with ideas like this that, you know, at the time everyone was just making this stuff up, and somebody will have just come up with this idea and put it in, and it's just stuck. But also, there's been so much evolution. You know, when I was talking to the creator of C++, one of the videos you can go back and watch, and we were chatting about that evolution of the language and how stuff just keeps getting added and added. And the depth of things that I think you get in something like Common Lisp is quite exciting and interesting as a way to learn. And there are often things like this that when you come to the language you work with day to day, you find yourself really missing because you've found it somewhere, you've loved it as a feature, and you wish you could have it. So yeah, nice, good find, Erik. So next up we have Glenn's solution in Tcl. Sometimes I call this TCL, but it's not. It's pronounced Tcl. Erik, do you want to talk us through what's happening in this solution?
The thing here is that Tcl is a very meta-y language where you can introspect things. So you have the set pling 3, set plang 5, set plong 7. So that's defining variables. So the variable name is pling, and that is not coincidental. We're going to use that fact. So we have drops equal to an empty string, but then we do the interesting bits. The thing where you have the square brackets is where you execute a command. So we're executing the command info, and we're saying, give me all the variables that start with a capital P. And then you can iterate over those. So that's now very interesting. So we have a variable defined, but you can also use code to find those variables and work with them. So we can then, the if statement will be very similar-ish, but the thing that we have is the $var will be evaluated to the actual value. So that will be 3 for the pling variable and 7 for plong. But we can then append the variable. So I say $var evaluates to 3. That's not true. The command set with the variable evaluates to the value. So the square bracket set $variable will return 3 for pling and 7 for plong. And then if that the remainder is 0, then we append just the variable, which is the string pling. And then in the end, it's a nice short expression to get the result to see if it was empty or not. But the key thing here is we're using a command to get all the variables that start with a capital P, and then we can iterate over those. So I find this a really nice meta solution.
Nice. So yeah, this idea that the square bracket set var gives you the variable's value, but just the $var gives you the variable name is really interesting, and I guess sort of abused here by Glenn, but also really really nice, really elegant at the same time. I absolutely love this idea of get all the variables that start with capital P. I mean, that's fantastic. That ticks all my meta programming boxes that I love. It's a really cool feature. Okay, so moving on. So this is an interesting solution. This is an Elixir solution. And I guess this starts to move us in a little bit into generally the idea of solving this in a more complete way. And you'll see what I mean when we get to the next solution in a minute. Yeah. But the idea of rather than sort of building things up one by one, we actually more completely say, well, hold on, there's only 3, 6, 7 cases that are actually going to be output, and plus the integer string. Let's look at those. So yeah, talk us through this, Erik.
Yeah, so this person has definitely analyzed the exercise well. Well, 3, 5, and 7 are co-prime, which means that they don't share any factors between them because they're all primes. And then it means that you can just do 3 multiplied by 5 multiplied by 7, and then if the remainder of that number is 0, then it must be a multiple of all those 3 of those factors. And then the same applies to 5 and 7, 3 and 7, 3 and 5, etc. But you basically have all the options here. And I think this is actually quite readable. And you can also sort of see the symmetry.
Mm-hmm.
And this is a completely different way of looking at it. Instead of having these if statements and for loops, etc. This is just looking at it from a numerical standpoint and what are the actual allowed values. So I quite like this, actually.
Yeah, me too.
It has duplication, but I don't mind it.
With Elixir. Yeah, exactly. And yeah, if you're not familiar with Elixir, these are guard clauses. So the code will run if you call convert, and it will go from top to bottom until it matches one of these guard clauses. And then the one at the bottom with no guard clause, that's just the fallback. So we're avoiding having to do any if statements or anything like that. We're just using these guard clauses. We looked at a similar thing. I can't remember if it's leap or reverse string. But yeah, I think I agree, Eric. It is really readable. Like you can, again, it's not necessarily very extendable, but yeah, it definitely for what it is, for understanding the exercise, understanding, like you said, that they're prime numbers. Makes this really interesting. And then, as is his way, EE7 has taken this one step further in his solution. This is NIM. I think both of us, we really like this. And then, we got talking last night as well about whether you could use the same solution for solving leap years and other things. So yeah, tell us what's going on here, Erik.
Okay, so this is based on the same thing that we saw previously, where it is possible to know which numbers will get assigned which string. So we're using the fact that 3, 5, and 7 are co-prime. So if you multiply 3 by 5 by 7, I think you get 105, if my math is now correct. So there are at most 105 different options. So if you have the number 3, you get returned pling. 21, you get returned pling plong, etc., etc. But there are only 105 options, and that's a key observation here. Another key observation here is that we can actually calculate these beforehand, because we can just do a loop, and we can calculate an array of 105 values, and then at runtime we can just look into that array. And then NIM can take this even further, because NIM allows you to execute code at compile time. So as this whole list of those, that array of 105 elements is static, we can actually calculate that at compile time. So that's what's happening here. So const at the top means that this is executed at compile time. So you can't make everything a const. It has to be a constant value. But in this case, we're executing a block of code, which has, we know this. We know the drill now. So the raindrops is an array of tuples. But then we have calc period, and that could have been just the number 105. This is just to make it a very extensible version if ever a raindrop gets added. So this will just multiply 3 by 5 by 7. And then you get the number, the length of the array. So on line 15, you can see that the return type of the gen lookup function is an array where the amount of elements is equal to calc period. So that's 105. Just read that as 105. The value that gets returned is an array of a number to a string. And that string is, of course, a return value. And then within that function, if you don't know NIM, this will just be line 16 is for is iterating over the key value pairs. Then we're iterating over the index and the string. Sorry, I'm saying it wrong. Line 17 is iterating over the key value pairs. And then basically for every one of those options, so every one of those elements in the array, we're pre-calculating whether or not what the resulting sound is. So this is just our regular loop. that we saw previously. S.add is just adding it to the string, but we're adding it to the string that's already in the return array. So I don't think there's anything particularly different about that. But on line 23, we return the gen lookup function, and that gets assigned to that lookup const. So everything that you see from line 1 to line 23 is executed at compile time. And then at runtime, the convert function, the only thing that it needs to do is it can look up the input number modulo the number of values in the lookup table. So if you know a bit of your modulo logic, you'll see that if you have the value 3, it will be pling. But if you have 105 plus 3, that will also be pling. So you can just do the modulo version there. And this means that at runtime, this is completely branchless. You don't have to branch, you just have to index in an array. So it is very hard to beat this code. I don't think it actually, it might depend on your language. If you can do the same thing, that it might generate a better version, but probably not. This is just really, 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 really fast, and it completely works, and it's really cool. It has the only downside, it being that compile time could be slightly longer, but this is just a very fast thing to execute. So I don't think you'll even know. So.
Yeah, slightly long compile time, slightly bigger binary, but a tiny, tiny amount of slightly bigger. Yeah, I was really impressed when I saw this, and it got us talking about leap years. We recorded the leap video a few weeks back, thinking about, could you do the same thing for, I don't know if we came to a conclusion last night, but you could probably calculate all the leap years between year 0 and 2000 or 4000 or some year, and then anything after that will just fit the same pattern that's already happened. So that might be an even more efficient way of doing that exercise as well. But yeah, I love this. Credit to E7. E7 is always someone that's looking to optimize every millisecond and every byte, and does a great job across a lot of Exercism's tooling, helping us out with that. But yeah, love this one, Erik. Really cool. And that brings us on to the final solution, which is, about as far from the one we've just looked at as you can imagine. I haven't yet worked out how I'm going to try and display this in the video, because the solution is made up of 1, 2, 3, 4, 5 different files. But this is an object-oriented approach. So talk us through this, Erik. Tell me where to start, and I'll probably try and show the files as you're talking us through them.
I'll again preface that this is not the idiomatic Pharo solution. This is just to show that this is possible. But the thing here is that this person identified those pling, plang, and plong sounds as basically objects. So you have a Raindrops class, and that Raindrops class has a lot of code that we can just forget for now. Sound has helper thingies. So you get sound has a convert method where it says number divided by a factor is 0, then you return the class name. So you can see here that this will return pling for the pling class. Otherwise, it will return the empty string. So this is the base class that the sounds are actually extending. So if you look at plang.class.st, you see at the top that there's a class. The name is plang. That's what being used previously, but it has a super class. So it is an instance of the sound class 2. And then the only thing that's really different between pling, plang, and plong classes is that they have different factors and different names. And that's all that there's to it. So it's the same, the variant that we had in, the Scala one, where you had the name and the factor in a map. But this is the same, but in an object-oriented way. So the objects have knowledge of the factors. And then the Raindrops class itself is using this, and it will, if you look at line 21 in raindrops.class.st, you'll see that it collects all the subclasses of the sound class, and then it creates a new instance of it, and then it sorts them by factor to make sure that the very first subclass is the one that has the lowest factor, because Plang is, I think, the first one listed alphabetically, but it has a factor of 5, so we have to do something about that. And then in the convert number method on line 11, it's actually iterating over those sounds, and then, well, it's a different way of writing this, because Pharo has a syntax that people might be not used to, but it's doing the same logic where it says if it is not empty, then you do this. If it is, you convert it to a number, etc. So we don't need to go into the details, but the thing here is that this is an object-oriented approach where every sound has its own class. And this is, of course, very extendable. You just create a new class. And as long as you make sure that the class name corresponds to the right sound, then it would be working still.
Nice. And one of the key things that works here as well is that you can do sounds subclasses. I don't think all languages, I'm trying to think if something like Ruby can do that, but you can always get the parent class of a class, but to be able to say, okay, give me all of the things that have subclass sounds is one of the key little details that I think makes this work quite nicely, because otherwise you would have to hard code in that list somewhere, and that would wreck the whole thing. So definitely an extreme version, if you like, of doing this. But I think a really interesting one. I think if there's a lot of sort of boilerplate in Pharo with the class definition at the top and things, which I think makes it look a lot more verbose than it is. Whereas actually, there's only really probably 10, 12 lines of code in this solution. It's just spread over so many files and so many things. But this is probably also the least efficient way of solving this. I imagine there's a lot of extra unnecessary memory allocation and everything else. So it really contrasts with the NIM one we just looked at. But maybe this is a more sort of software engineering-y sort of approach to it, some people would argue, whereas the NIM one is maybe more of a hyper-optimized sort of version of it. So that's it. Those are all of the solutions that we're looking at. There's one more thing, though, that we wanted to take a look at, and that is that we talked here about Raindrops, but we mentioned at the beginning that this is based on the FizzBuzz exercise. And Erik, you found a great repo on GitHub that makes this fun.
Yeah, this was actually found by Aaron, by the way. So he just forwarded it to me. Nice. And this is ironic. This is just having a bit of fun. But what it tries to do is, because FizzBuzz is actually a very simple thing, because there's just a couple of if statements, a bit of string concatenation. But what if you take it to the extreme and you create enterprise FizzBuzz? So you have loggers added. You have strategies to create raindrops. You have a lot of classes. You have visitor pattern. You have factories. It's just incredible. So they've tried to create the most complex way to implement FizzBuzz, and they call it Enterprise Edition because it has all the enterprise features that you want, logging, etc. But I think it's it's a fun thing, just as a sort of satire on what software engineering can also be, like wildly over-engineered for a very simple thing.
Nice. Thank you for sharing. Yeah, I think that's when I saw that, my mind was a little bit blown. Not only that it exists, but that people have gone through all of that effort to actually make it and build it out. I mean, there's a labor of love that's happened there by somebody who's, really trying to make a point.
It has over 400 issues, so people enjoy this.
Wow, I didn't even notice that. Wow. Yeah, you're right. 85 closed issues as well. Tons of pull requests, 113 closed pull requests. Wow, that's good. I like the fact someone's got a thing saying not enough comments, adding tons of new comments as well. Yeah, there's definitely somebody's labor of love. I mean, a lot of effort has gone into this. So yeah, either a labor of love or maybe something they're really trying to make a point about. But yeah, super cool. Okay, so that's the end of the video. I hope you enjoyed watching it. If you have solved Raindrops in one of the more basic ways, maybe you want to go away now and try and do it in one of the more inspired, complex ways that we've seen. Maybe try and do something a bit compile-timey, a bit object-oriented. Maybe find some unique features of the languages that you like that mean you can do it in a particularly unusual way. Thank you for watching. Thank you, Erik, for choosing those solutions and talking us through them. And I'll see you all in the next video.